Here is the summary of this video. What is the issue? Lorentz transformations are the foundation for relativity theory calculations, such as the gamma factor, kinetic energy, and the addition of relativistic velocities. If the derivation of the Lorentz transformation was false, the theory of relativity would collapse. In this first video, we will critically examine on the one hand the hypotheses on the reference frames, and on the other hand the beginning of this derivation with the conditions on y and y prime. The hypotheses. Let's take two reference frames in uniform translation with respect to each other. The first is the blue reference frame S, the second is the red reference frame S prime.
So that the event x equal to 0, x prime equal t equal to 0 also had coordinates x prime equal to 0, t prime equal to 0.
By t prime. Now we're assuming at time of t equals t prime equals 0 seconds, the two frames are superimposed. They are found at the same exact position.
Initially, at t equals to t dash equals to 0, the origins O and O dash coincide.
It is therefore necessary that the origins of the frames coincide, and that at this instant the clocks synchronize. This means that it is not a question of any general reference frames, but of specific reference frames corresponding to these four equations. Here are the two frames of reference, each origin of which moves on the same x-axis. The derivation.
So at time of t equals t prime equals 0, let's suppose a photon of light, a single beam of light, leaves the origin of both frames.
From the perspective of this observer, for him the bulb went off at his origin, right? But after some time has elapsed, the light moves out in the form of a spherical wavefront, which looks something like this. Okay, which has a center at his own origin of his frame of reference. From this person's perspective, however, the light went off from his own frame of reference origin, and after some time has elapsed, the light will move out in the form of a spherical wavefront, something like this.
Now let there be a point source of light at origin O.
Another peculiarity of this demonstration is that the light wave must start when the origins O and O prime of the reference frames coincide, and only at that time.
Means the photon travels a distance of x prime equals c multiplied by t prime, where t prime is now our time that has elapsed within the frame f prime.
So time here we will get under root x square plus y square plus z square upon c, or we have x square plus y square plus z square is equals to c square and t.
Equation for the spherical surface at point P observed by the observer O dash is written as x prime square y prime square z prime square is equal to c square t dash square.
According to the second postulate of the theory of relativity, the speed of light is equal in the referential frame S and in the referential frame S prime. This gives a total of 6 conditions. This means that it is not a question of studying all the light waves, but only a very particular light wave emitted in O and O prime at the instant t and t prime.
Since frame S dash is moving relative to S along x-axis, length in the direction perpendicular to the direction of motion are unaffected. So we have now y dash is equals to y and z dash is equals to z.
But not only is that taking place, length contraction is also taking place, and that's why we're multiplying that by alpha. Now notice that the reference frame is only moving along the x-axis. It's not moving along the y-axis, and it's not moving along the z-axis. So that implies the y-coordinate will remain the same, and the z-coordinate will also remain the same. So y equals y prime, and z equals z prime.
We can write y is equal to y dash and z is equal to z dash.
Criticism. To simplify, rather than studying the propagation of the light wave in a three-dimensional space, we will study and represent it on a two-dimensional plane in x and y. According to the theory of relativity, y prime equals y. Hypotheses E and F can be written according to equation 2 in Cartesian coordinates. Here is a representative drawing. Let's take an example to fix the ideas. Suppose that the referential S prime moves away at a speed such that its proper time is divided by 2. We get that the radius of the sphere is divided by 2, it is the contraction of the lengths. In Cartesian coordinates we get that sinus theta prime is equal to twice sin theta. This is impossible for sin theta greater than a half. Let's continue with our example. Consider the case where theta is less than 45 degrees. Depending on how we calculate the radius r prime, we don't get the same value. It's not consistent. Result: we cannot demonstrate that y equals y prime. This is because, on the one hand, the calculation is impossible for large theta angles. On the other hand, for small angles, the direct calculation of the radius of the light sphere is not consistent with the calculation in Cartesian coordinates. And you, what do you think?